The Thinking Machine, how AI learns and what it teaches us about business. I'm Femi Ibamiji. I have a decade of experience in data analytics, machine learning, and automation, and I'm excited to be with us here today. Now, when I say the thinking machine, what do I mean in reality? Let's start with these quote that pops out of a white paper from PwC that is declaring artificial intelligence the biggest commercial opportunity. And of course, when we say something is biggest commercial opportunity, of course, we exist as a business in the first place because there's an opportunity, a commercial one at that. And now AI has been declared the biggest commercial opportunity, and it's going to be contributing 15.7 trillion 15.7 trillion to global economy by 2030. But the question you would actually ask is, what does 15.7 trillion look like? Is it the robot? Is it going to be like the next Terminator robot? No. This 15.7 million trillion, if you look at it from the white paper, is actually talking about how much personalization, how much product enhancement, how much demand stimulation that these technology called artificial intelligence is going to bring to the business world. It's talking about how AI would come to make business forecast better, to help business makes better decision. How AI would come to just, and of course we already have the practical use cases all around us. Look at Netflix. I'm not a movie person, right? I hardly watch movie, but there was a time a blockbuster was released and I quickly just subscribed to Netflix, wanted to just watch the movie and then I'll be off. And then of course I check out a few other movies and guess what? The next morning when I opened my Netflix app, Netflix was already suggesting similar applications to me, similar movies to me. And then I was, they were like, it was like Netflix was actually reading my mind. So gone are the days where it's because I open a category. Let's say I open a category of horror movie this morning. I have to just see your watch this. They are just going to be all about horror movie. It doesn't mean I like watching horror movies. But today, every click, every pause, every play on Netflix is actually something in the background, reading your pattern, something in the background, noting down your behavior. And then it's going to use that behavior against you. So let me put it that way. Like the next time you come in, even if your mission is not to come and watch a movie, because you are now seeing movies that are very attractive to you, that actually speaks directly to what you want to watch at that time, you get stuck. And trust me, for like 1 month later, I was on Netflix. At the point, I had to transfer it from my laptop to my TV so that I'm able to focus on other things on laptop. And then I turned it to one of my multitask items. So, but in reality, what am I trying to say is this is how AI is coming to the picture, not just in the entertainment industry, across different industry. And then, of course, let's see how this flows in. Now, what is this AI? How does it work? What let's even bring it down. Let's just talk about because it's not robots. Just like I've said, it's not that big robot. It's not just, of course, that can be part of it, but that's not just what we are talking about when we say it's $13.5 trillion. Now, human cells, I can learn everything automatically from experiences. Can you learn? And machines say, yes, I can also learn from past data with the help of machine learning. So imagine you are just trying to create more machines that, of course, no fatigue, no break, no leave, that can actually think along with you and also create results. And so machine learning is simply when we say machine is learning, it's nothing complex. And we just say, I take a machine, the machine can live in anything. It can live in a small device, in your wristwatch, on your websites, anywhere. And I can give it a past data, I can give it a past experience, and it can also learn like human. And based on that learning, it can take future actions. That's machine learning. So it's using data and algorithm to imitate how humans learn, and it gradually increases its accuracy. And this is very different from how traditional software works. So I know someone might be saying, "Yeah, I'm a software engineer before." Of course, in our company, we build software, we make rules. If this person has an account in Ghana, then he should not be able to create a US account. If his account is created in Canada based on the GPS, then he can't pick a currency that belongs to Ghana. And then, of course, that keeps flowing. But remember, those rules sometimes women can outsmart them. They are not going to tie down someone that's an hacker that wants to hack your system. So, but machine learning does it differently. It flips the coin. Data, you inject the data, give it the examples, then it can use that to create output on its own, just like human. Now, let's take a pause before we go further. Off the top of your head, I want you to just think of three important organs you've used today. Three important organs. You can drop the answers in the comment box. Or I'd love this to be a poll if this is a kind of a live interaction, but you can drop the comment in the poll. Why I continue? I believe you've done that. Okay. Now, from my previous polls, where I've taken this in classes, it always boils down to majorly your eyes, ears, and mouth, our brain, and the rest of them. Now, we can actually relate this back to this AI we are talking about. So, building a model, building an AI capacity that has the power to see and interpret images. We've seen it in object detection systems, in industrial use cases, and the rest. That's giving the computer an eye. So, anytime you hear computer vision, we are simply saying we want to give a computer, it can be your wristwatch, it can be anything. We want to give that thing an eyes. And when your computer can interact with you, like ChatGPT, the way it interacts with you, you can ask questions, you can have interactions, meaningful interactions, understanding and communicating natural languages. That's the ear and the mouth. Giving your computer ear and mouth. That's called natural language processing in the technical terms. And your brain is machine learning. That's your model, basically taking the brain, like when you give birth to a baby, he doesn't know anything yet. You send him to school, he starts learning start learning characters, moves to numbers and the rest, and then before you know it, he's already an engineer, and then he starts building something meaningful. That's the same flow that machine uses to learn. So now, do you remember this chart from secondary school maths? This is of course you have this equation, you have your x-axis, your y-axis, and then you would even say I can draw something from here. If they say, oh, predict new points at this point at 80 naira or $80 spent, how much will be my sales? We can trace with pencil to the line of feet, and then we get a new point. And they told us the equation was y is equals to mx plus c. Now, this, of course, this is just talking about how prediction works in mathematical term, in reality. Where it sales is 2.5, that's your M, which we call the slope or coefficient. And it's simply saying for every $1 spent on ads, how much sales increment or decrement will I have? So that's what we call, that's why you would see my question. I wrote 2.5 times ad spend. And then the bias, which is the C, is just saying if I don't spend anything, it doesn't mean I will not sell. How much will I sell? That's best sales. Best sales when ad spend is zero. And that's my term. And of course, this is one value versus this. This is done in the world of Python, technical terms, as just saying, picking an algorithm and using a dot fit on it. And then when we want to predict tomorrow, if we spend $20, what will it be? Now, if we have gotten a very good equation, it's easier to just plot in the $20 into the equation and you get how much sales you will make. You've already done a prediction. And this can scale from 10 records to 10 million records. That's the foundation of forecasting, foundation of machine learning, as I'll call it. So in reality, but there is a kind of a pause here. Imagine you have a single doctor and you have a tumor board of specialists, and you have a patient that needs to be attended at the hospital. Which would you prefer to attend to your patients? Of course, the tumor board. Okay. And the scenario in our previous slide is just one feature, one rule. So woman can say, I can go into my Excel and do this calculation. But reality is that business decision is not that simple. It's not just about your ad spend. It's about your pricing, your competition, your seasonality, your geography, a lot of other things that makes up what determines that sales. And AI has the capacity to do this. So at the end, we are moving from just coding, from the era of just having robots, to a system, a machine that creates values. And it's doing this across industry, detecting fraud before it happens, diagnosing faster, saving lives, forecasting demand, personalizing experience, recommending, retaining, and engaging, revolving around value. And this is what brings us to digital transformation. It's not about replacing people, it's about you bringing your best, machine bringing its speed, its processes, and then, of course, you scale it in to achieve your best results. So, guys, it's not about just machines. It's about moving from prediction to possibility. So next time Netflix shows you that movie to watch, it's actually precision. It's actually a machine learning behind the scene trying to create a business result. And right here, you need to ask yourself, what could you predict next? What you predict next could actually be the changing factor. for your business. Thank you.